Assalamu alaikum. So in this problem, we are given an integer r. Suppose we are in 0, 0 position. So we have to calculate the number of positions. Where if we go, the Euclidean distance will be uh, better than or equal to r and less than r plus 1. So this is the equation for Euclidean distance if the point is xy. Okay. Now, if we consider r equals 3, then these green points are the points uh, those satisfy the condition. Okay, if we consider this point and the value of x is 3 and the value of y is 2, so d will be root over 3 square plus 2 square. That is something 3 point something. Okay, so this point satisfies the condition and it belongs to uh, the answer for r equals 3. Okay, if we consider this point here x equals 3, y equals 3, and d becomes root over 3 square plus 3 square root 18, and it is 4 point something. So this point contributes to the answer if r equals 4, but if r equals 3, this point do not belong to the answer. Okay. So how can we calculate these points? There is an important note that the sum of r over all test cases does not exceed 10 to the power 5. That means we can kind of iterate through the x or y. Here d equals root over x square plus y square. So if we iterate through x, then the minimum value x minimum will be 0. Okay. If we consider x to be 0, then for satisfying this condition, y have to be r. Why r? Why not r plus 1? If we consider r plus 1 here, r plus 1 square, so d becomes r plus 1, but d must be less than r plus 1. Okay, and what will be the maximum value of x? Maximum value of x is r, because if x is r, then maybe we can add, we can say that y is 0, 0 square. But if x becomes r plus 1, whatever value we provide here, maybe we can provide 0, 0 here, 0 square. The whole value of d will become r plus 1. But it, it is said that d must be less than r plus 1. So what we have got is the minimum value of x is 0 and the maximum value of x is r. So we can iterate from 0 to r, and in each case we want to calculate the number of y that satisfies the condition. Okay, so we will iterate from 0 to r, and for each value of x there will be will be a low and high. Okay, low means that the y starts from this position. Here, if we only consider this box, the first coordinate, then the low will be 0, the high will be 2, and it is for x equals 0, 1, 2. Okay, now, okay, now if we iterate from 0 to r, then for each case we will find a range of values, a range of points. Okay, for this case we have got these 3 points. For x equals 1 we have got this point. For x equals 2 we have got these points. Okay, this one is for x equals 3. For x equals 1 we have got this point. We can see that this point is similar to this point, and similar to this point, and similar to this point. Okay, again this point is similar to this point, and this point. So we will only consider the first coordinate, and whichever point we get, we will multiply it by 4. That means we consider it to be in all 4 coordinates. But there is a corner case. For example, this point is not in 4 coordinates. So for this point, we can only consider this in the answer. And for this point, we can only consider this in the answer. So when x equals 0, here x equals 0, and low x equals 0 or low equals 0. In this scenario, the point only contribute 2 times, and in all other cases, the point will contribute 4 times. Okay. So if we see the code, first of all, there is a test case given, then a value of r is given. Okay. Now we are iterating x from 0 to r. Then we are fixing low and high values using two pointer or any other approach. I have used some approach like two pointer. Then we have calculated the number of values, the number of points of y which satisfies the condition. Then I have added it to answer. Here it is multiplied by 4 as I have mentioned earlier. If not x or not low, the value of equals 0 or value of low equals 0, then I have added 4 times a particular point, but this particular point should have been added 2 times. So I have to decrease my answer. So I have done it here. Answer minus equals to, and finally I have printed the answer. Okay. Thank you.